But you should be able to install it from the Anaconda prompt and then run it. Maybe we do this after during.
Yeah, it's okay.
Because we're going to start now the presentation.
Okay.
It's the correct Python.
Let's see. I think that there's a path problem.
We can check it after the talk.
Okay, yes, you may see that Python is pointing to Anaconda shipping Python, and this is pointing to Open Anaconda. So if we do this, command.
Yeah, there's classic mismatch Python version.
Command C.
So now it's installing the in the right environment.
Okay, thank you. Thank you.
You're having two environments running at the same time.
Thank you. We can start, I think. Right?
Wait a minute still.
If there will be something who is talking about.
We have here.
But let's wait a minute.
Still some more struggle. I think we can start. I don't know if we're supposed to be introduced or something. I think we can just start.
Okay. Okay. Hello, everyone. I am Grzegorz Bokota, here's Lorenzo Gajtas, and we would like to provide you today the tutorial how you might use napari, how you might customize napari. We both started our journey in napari as PhD students who just need to improve something in napari to simplify writing PhD thesis. Now we are in the happy situation that there are funds to pay us for doing open source. So, okay. So what is napari? Napari is multi-dimensional Python native and hackable viewer. Who of you already use napari?
Okay. A lot of newbies then. Good.
Okay, so the QR code is a link to our webpage. The interface you see on the right. So as you can see, this is a 3D image rendered. So not so many people are knowing Napari, so maybe you have something to add to introduce.
Well, we're gonna go a bit more into detail in the interface in a moment. Just the general idea of Napari is to be a highly hackable, interactive interface with your imaging and imaging-related data, so that at any time you should be able to access the data both from a graphical interface and from a programming interface in a seamless way. And that's what Hackable also relies on. And today in the tutorial, basically what we will do is we will go step by step constructing a Napari plugin to do a specific task of image segmentation, starting from a pure Python function.
Okay, so here you see the list of supported types. In general, Napari models as okay, we have image with some, most often biological but not only data, and you would like to annotate it in some way. So there's image, there is label annotation, which is pixel-wise, there is a points, which is set of coordinates, shapes, you see shapes on the screenshot, tracks, surface, vectors. At this moment, this is the list, but it's not. We are not close to adding new types if it's reasonable. Okay. So in the description there should be a link to these materials. I hope, but who of you already set up Napari?
No one. Someone. Yes. So there's some instructions in the README on the repo that we linked. You're gonna see them here as well. We used UV to install, but you can use whatever methodology you normally use.
We put here UV information because pip and conda instructions are already in the documentation of the project.
Yeah, so you can just.
The important thing is to remember to install some Qt backend because. Oh.
Yeah, it keeps coming and going. Yes. You should be able, using UV, to just run UV sync, and it should install things already. Otherwise, basically what we're using here is only Napari and Scikit image and Scikit, which anyways comes with Napari already. We are going to show you now a little showcase of the interface. In the meantime, you can finish installing. If you have finished installing, you can just follow along by just opening the PI, the presentation.py file that's inside the repo after cloning it. And you can open it in Napari, and we're using Napari to show you the presentation itself. So yeah, this is, we just converted the presentation into a 3D image, where each image is one slide, which slice is one slide. So you can see at the bottom, there's a dim slider. That's a slider that allows you to slide through the non-viewed dimensions. In this case, this is a 3D image. So we have the first two dimensions displayed, and the third we are slicing through using the dim slider. Depending on how many dimensions you have, you're going to get more sliders that are being populated automatically. On the top left, you can see the layer controls. Those correspond to the controls of the layer that's currently selected below. So, for example, yeah, there's some basic interface for stuff like opacity, the blending. This is an RGB image, so it doesn't have a color map, but if this was just an intensity image, it would have the color map selector. You can see below that there's a few buttons. Those are the buttons to create new layers, and below there's the layer list. Layers here basically function similarly to how they function in Photoshop or other image editing software, where basically the ones at the top are the superimposed on top of the rest, depending on the blending that is selected. And you saw here Jaggers created a labels layer and then generated some labels based on that, and by changing the opacity, it hides and reappears. You can also rearrange the layers in the layer list by just dragging and dropping, and of course it will affect the blending. You also saw that when you change the selection of the layer control widget updates with the controls of the currently selected layer. And the labels, as you can see, has quite a bunch of stuff up there. There's a few buttons to create, edit, modify manually labels in different ways. At the bottom left, there's a bunch of buttons that are just general viewer tools. You just saw Gregor pressing the console button. This is just an IPython console that's linked to everything that you're seeing in the GUI. So if you do something in there, it will be reflected immediately in the graphical interface and vice versa. I didn't see what you did. Ah, yeah. So if you print the viewers, the layer list, which is inside viewer.layers, you see all of the layers that are currently in the layer list on the left. Okay, it's changing the size so you can see better. The other buttons allow you to switch from 2D to 3D visualization, rotate dimensions, enter grid mode, or reset the view. You can index into the layer list as a normal list, but also using the layer name like it's doing now. And here we can modify any attributes of the layers, for example, the visibility, and immediately the layer becomes not visible in the canvas. You can also access directly the data of the layer, and the data is typically just a NumPy array or some other array that matches the array specification. And you can modify that data from the GUI or from the command line, and vice versa, and it will reflect directly in the viewer. You can go to the next slide. Yes, so there's at the top there's a bunch of menus, and these menus contain a few things. For example, there's a few overlays, and we're working on more now. Right now there's the overlay for the color bar, not the color bar, the scale bar, which updates automatically as you zoom in and zoom out. You can customize it in different ways. There's also an overlay for the axis and so on and so forth. And also all of the plugins that you will install in napari or develop can provide entries for the menus, and we will do that later when we build our own. Finally, one thing that we recently implemented, which now we've been using all the time, is the command palette. If you press Control or Command plus Shift and P, it opens this menu where you can just type out part of a command, and it will execute that command. And this is basically going to show every entry that is also in the menus, plus some other stuff that is not in the menus, but it's just an action that's available. And this is something that you also contribute to using a plugin. Another thing that we implemented recently, which is pretty neat, is the ability to change the thickness of the slicing. So if you, let's see in 3D first. Yeah, you can. So just to show that this is just a 3D image where we just change the scale of one dimension so it's thicker, so you can see. Otherwise, it would be very thin. But yes. And if you right-click on the slider and change the thickness, we are actually gonna be able to see through multiple slices. This is very useful when you're working with noisy data, and sometimes you want to see an average over several slices, for example. You can change the projection mode if you go to the top left. Right now it's by default on the mean, but you can do the sum, and now we're going to see the surrounding 3 slices here. I think you selected. Okay, I think this is everything when it comes to the. Yeah, we want also to showcase the plugin. Do you have a plugin installed? No, not in.
So.
Yeah. Yeah, we can show there's the plugin manager. So here you can search for any existing plugin that's published on PyPI. And for example, now we're installing Napari Animation. Napari Animation is a plugin just like any other. It's a bit complex, it's more complex than the one that we will do later, but it provides an interface to generate animations that are controlled via key points, keyframes, and basically interpolation between the various keyframes. So you can change various parameters of the viewer, lock into a keyframe, change a few other parameters, lock in another keyframe, and then generate an animation out of that. We don't have to do it now, anyways, it's going to be slow. But just to show that the plugin interface allows you to do pretty complex stuff. For now, what we will do is a simple functional plugin widget, and we'll get into that in a moment. And I think that's all for the introduction. Are there any problems with installing Napari? Are you managing more or less? Otherwise, as we go on further, lift your hand and go, and one of us will come and help while the other is continuing the explanation. Any general questions on this part? All right, cool. Then we can continue. So the tutorial itself, we kind of followed the general process that usually happens, or has always happened to me when working on something with Napari, which is you have some Python function, some procedure that does something to your data, and now you want to make it so that it's interactive, more easily parameterizable, and then also shareable. So we start with a very simple Python function, and you can follow along. We basically incremented the amount of information in the code. You start from the 0.1 and go all the way to 0.8, I think is the last one. And we start with a simple pure Python function that should be familiar to anyone. Can you show the function again? So it should be familiar if you have worked with NumPy and similar things before. All we're doing is just apply. Yeah?
Can you use the size of the video?
Yeah. Maybe full screen as well. And yeah, so we are normalizing the data, applying a Gaussian filter, and then applying a threshold to that, so that we get out yes or no, are we within our realm or outside of our realm. Down here, all we're doing is we're opening the viewer, loading some data, which comes from scikit-image, and adding it to the viewer. And then we're applying our threshold function. Our threshold function just spits out a Boolean array, and we then add it to Napari as a labels layer. And you can just drag and drop this, by the way, if you open Napari, just drag and drop .py file, and it will run hopefully fine. It's a thing we added recently. So. And the result that you will see is this. As you can see, we have 2 layers, the image that we loaded, which is just a 2D image for now, and it's a slice through some cells, and nuclei of some cells. And then we have the labels. Yeah?
In the code, why did you slice 31?
So this is a 4D array that comes from scikit-image. It's 4D because it's a 3-dimensional array. We'll get to that in a moment. It's easier to work with 2D for the beginning. And then the fourth dimension is the channel. There's actually two channels. Actually, the second dimension is the channel. The first is the Z, and so it's a bit weird, but whatever. So as you can see, our blobs, which is the labeled data, we just got the highlights over there. It's now in brown. And of course, when you get to this point, you run your function and you're like, okay, clearly the parameters are wrong. I need to change the threshold. So let me change the threshold. Then you go in and type a new threshold, then run it again, and go on and hopefully find a good threshold. Or you have to find some smart way of guessing the threshold correctly. But it would be nice if you could just do it on the fly.
Okay, so I think that maybe it's a good moment for. I think that's a good moment for you to validate if everything's working. So maybe the first task is for you to just execute the example. Just go to the moment where your code, you see this sign like we see. As you might see, I may reproduce what I do to get this. I just close, open the file, drag and drop. One remark, if someone has older installation of Napari, not from few recent days, it might not work. Because drag and dropping Python scripts is developed especially for this conference. We merged this 2 weeks ago, released 3 days ago.
Yeah. Woo! High speed. Yeah, so if anyone is having problems with this, you can raise your hand, ask a question. Yeah?
So if I edit something in the file, how will it get restricted to this viewer?
I missed the beginning. If you do what?
If I edit the file, will it get restricted in the viewer?
No, if you edit the .pi file, you have to re-drag and drop it in order for it to work. Yeah, it's not somehow live checking the Python file. That would be cool, though. There was something else here?
I might show that you should also remove the previous layers, because if I drag and drop second time, it adds new layers every time.
But since we're not doing any crazy like persistent modification, you can just delete the layers, re-drag and drop, and modify and try again. So you can, if you want, try to change the threshold manually, and it's going to do the thing you want. One thing we wanted to show at that point, you can also look at the original 3D data. This is it. We'll get to it later. Can you reopen the .pi, and then we show that in the console you can even run the threshold function, right? Because we have this Python function, and the console is linked to whatever Python code we ran before. So it's the threshold function that we defined is available here, and we can just run it. And for that, we have to pass in the layer data. So you have to fetch first the layer and pass it the data. And what we get is exactly the same that then we use to create the blobs later.
So I think I missed it. How do you load the image data?
Drag and drop.
From the, is it in the
The image data comes from, it's going to be downloaded the first time that you launch it. It's a scikit image thing.
Okay.
Scikit image has a .data module that automatically downloads a few data sets whenever you call them the first time.
Gotcha. Okay.
Yeah, we have the Sales 3D. When you call that function, it will download.
So yes, first time execution might be a little slower because of this download. Later it's cached, so
yeah.
Okay, so
other questions? Yes.
So if I like to call again the threshold function, like you were writing in the console, and changing the sigma threshold, I'm not noticing any changes in the.
yes, now you don't see any changes because you execute pure function. So you will see on when you execute the function, it returns the array. It does not do any changes. We might show, for example, here if we do.
You have to tell napari to add that array as a labels layer.
Blobs data equal.
Or just set the data to the new Yeah.
Sigma equal to 0, 1. No, no. What are parameters? The threshold 0.
Yeah, and we should see immediately the visualization modifier. Yeah. Okay.
So you see, there's need to assign the results to the
And in
data
fact-
if you work with the functions.
And another thing we can show here is that you can even modify this manually, right? You can go in and delete stuff if you want. Like if you just want to move on and be like, this is not my label, just whatever, and then move on with the processing, you can do that.
But of course, next execution will overwrite everything.
Yeah. Okay. So more questions on this? We're good. All right.
Who gets it working?
Okay.
Who wants to make more time?
More time? Yes. Do you need help as well? Questions, or is it just slow? Okay. Yeah, we can wait a moment. In the meantime, if there's more questions, feel free.
Why is disabled? Okay. It's disabled because of Boolean array.
Right. Yeah, so we already saw that you can switch to 3D by pressing the button there. We already were. Oh shit, I'm doing something weird. Okay. It's useless now because it's only a single slice, but you can do it. And most camera convention work. Sorry, buttons here at the bottom left. If you hover over them, it also will tell you a bit what they are. This is the switch from 2D to 3D. This will transpose dimensions, and if they have a little caret, whatever, the little triangle at the bottom right, you can right-click it, and there's a few more options. There are several things where you can right-click on the napari. We are trying to make it better communicated, but for example, the contrast limits as well. You can then modify also the range of the slider and stuff like that. Okay. Yeah, this is speaking of which, color map. As you can see now, it's selectable, and here you can easily change and
Maybe
go back to 2D.
blobs.
And now we have a different color map, and you can also choose existing color maps or define your own. Okay. So the next step then is, okay, how can we make this easier to interact with? And this is where we go from pure Python land to Napari land. And the big player here is a package called Magic GUI, which essentially takes a function and analyzes its signature and tries to generate a GUI based on that signature. And as you can see in the 0.2 example, we are doing a few changes here. The main block of the code is the same, but what we're changing is, as an input, now we're taking an napari layer instead of just the data. And as an output, we are splitting out this layer data tuple. And these are types that are registered in napari as Magic GUI special types. When something is annotated like this, napari knows that these things want a layer. So you will see in a moment what that means, but the important part here is that this needs to be annotated correctly. So you need to say what you want as an input there. You don't always have to. Like for example, below you see that we annotated float, but in principle you can leave it out because that's obvious that's a float, but it's better to annotate. The layer data tuple, it's a special napari type that is useful for this kind of application. And specifically what we need it for is that it allows us to return, yes, the data, like we did before, the blobs. In this case, we're returning actually two things, also the blur, which was the intermediate step. But it also allows us to return any keyword argument that will be given to the generated layer. In this case, what's useful is that we can give it a name, and the name will be used to update an existing layer if an existing layer of that name already exists. And the third element of the tuple is the layer type. In this case, it's not actually necessary, I think, but it will guess most of the times, but it's better to give it. So if we run this new code, a big change. Oh, wait, one thing that I forgot, if you go back in the code, there's also an extra addition which is down there in the main. We now have to add this thing. So what we do is give to the viewer window add function widget, we give our function. And this will pass it to Magic GUI and generate the GUI based on it. And as you can see now on Napari, when we run this, we have a new graphical interface on the right and a widget to modify these parameters. And now the layer parameter is populated with a drop-down. And the drop-down contains all the elements that are matching that time. So now we annotated with an image layer, so you will only get image layers up there. Can you show? If you click on the image, these are all images, so that's fine. But, and you can change those values, then press the run button, and it will update it accordingly. One thing that becomes useful here is the grid mode, if you can enable it. And then reset the view probably. So now what we did when you enable the grid mode basically is split up the canvas into a bunch of mini canvases that are all sharing the same camera. But now a single layer per view is shown, so you can zoom in and see the same feature in different layers. And now we have the several layers that got populated by the output that our function returned. And one is our original image at the top left, and you just go in from the top left to the bottom right, and you have then the blurred image and then our notation. And this is useful because we can see all of the intermediate steps and modify these values and run it and see how they affect the various parts. You wanted to say something?
Okay, so in the previous step, the blobs was the labels you see, now it's image. Of course, if you want to do this, we might just right-click menu and convert to labels. And you see here as a labels. But as you see the code earlier, we specify the layer type, so maybe you might try to just update the code of the function to see if it if you can change the type of layer to blobs we added as a labels, not as an image. You might see the difference between the labels and non-labels. That if you, for example, have this image one and we open this image, it hides everything. If we switch to the labels, it by default only hover the data. You might see it's still visible in the holes, the original data through the holes, and if we have opacity smaller, it's even better visible. So the task for now is to see the code, find how to change it to the labels, and maybe even set the different opacity to not be.
Yeah.
The opacity for labels is by default 0.7.
0.7, yeah.
But you might play it with. It's quite easy to spot this dict, and this dict is the place where you would like to put some additional arguments, like for example opacity, maybe blending mode, this things. So please play with it. If you could change this, if you could change the default opacity.
And if you go, if you type in the console viewer.layers and then index one of the layers, you can even just index with the just integers, so 0. Then you get one of the layers, and you can look at the doc string, and it will tell you all of the various attributes that you can pass. There's too many to list here, but.
And you might also spot that we provide one attribute by default, the name. Why the name is provided? Because if we provide the name in such situation, we don't, and it comes from the widget, it overrides existing layer, not adding new one. So whenever we modify parameters and click run, it is not creating new layers, but updating the existing one.
So if you do want to keep the various intermediate attempts, you can just remove that name something, and instead it will generate a new layer every time, and it will just give it a auto-generated name.
Or you might just,
Or rename
if you
it.
like some attempts, you might just edit in the layer with the name, and when you execute run, you see the blobs is added again because there is no such name or layer with such name.
Any questions on this part?
So I think we'll give a few minutes.
Yeah.
Maybe some questions will come. And maybe we don't show this fully. Yes, we don't show this. But the nicest things in the context of how we do this is that you see this type annotation napari dot labels dot image
Layers.
layers dot image. It could be provided as a string. You don't need to import napari actually to use this annotation. So even if your code, if you would like to have a script that is importable even without napari existing, and just be able to add functional widget in some other script, we are able to just use the string as an annotation. We just see, oh, this is one of the things that we recognize as our type annotation.
Is it working? Can you drag and drop this new script and it's doing the same? Okay.
And if you modify something, it doesn't explode, but do this what you modify.
Okay, so this was the basic Magic GUI experience. However, for me, the vast majority of times when I'm working with something like this, I don't want to be clicking or typing. I want to be sliding, and I don't want to have to press run. I want it to just work. So we can do both of those things now. If you move to the third example, the modification is very small actually, and sorry, it's inverted scrolling. Max. Yeah, no, because it's just the annotation up here that changes first. So as you can see now, we have this more fancy type annotation. There are other ways. You can go look up the Magic GUI documentation if you want. That's linked in the README. But one way to do it is to use this annotated typing system. And what we do basically is we add some extra arguments to the annotation. So we have, yes, the float type, but we also add some information. And here we can tell to Magic GUI we want a slider, a float slider specifically for our graphical interface. And you can provide extra stuff like the minimum, maximum values, so the range and the step.
And you see that still, with all this additional information, it's still pure Python function that could be called from other place. I would like to also highlight, because the annotation is also a way to document your Python function. And you see, even if you read this as a human, you see, oh, this function is expected float from the range to 0 to 2 as a sigma. So it's sometimes better than just float as a type annotation and going to the documentation and checking if they provide.
So this solves our first problem, wanting a slider. The second problem, which was I don't want to have to press run every time, is solved by telling Magic GUI autocall true. And here you have to do it by telling, by providing this parameter. And if you put these two things together, now we're getting to a place where this becomes actually usable for exploration of your data. And you can see now we have a different widget down there. And now, yeah, the first activation is going to be a bit slower, but then you can actually just move the slider and see immediately the effect of changing those parameters. Those parameters also are still a number that you can see, so you can still modify them.
Yes.
You can even...
You can just here.
Yeah. And if you go back to grid mode now, this is where I think it gets especially useful, because you can immediately see, as you slide the sliders, what effect the blurring has on the final segmentation. Okay, any questions on this? Is it working? It is working, that's not a question, okay. So, we can wait a second for this.
Yes, play a little with this annotation, so change the maximum value,
exactly.
see how it impacts.
Here, if you're not happy with the range, basically you can change this stuff however you want. And changing the step, of course, will change how finely you can control over this. By the way, everything in the... Sorry, go ahead.
Is it possible to have 2D sliders, or is that not a
2D?
As in combine two variables and then kind of like...
Just have... That's a good idea, but no. It's not possible with Magic GUI as far as I know.
Okay, the Magic GUI at this moment does not provide such a widget. If you, we are in the Qt world. If you are able to write a Qt widget for such a things, it is possible to register it as a data type provider in Magic GUI and use it.
Yeah,
so,
and you basically have to just provide a mapping of this. If you give me this type, you can return this widget.
A type annotation with tuple of float, tuple float. And then there is as far as I know, there is no registered widget by default in Magic GUI. I'm not sure, maybe someone registered such a widget. We don't meet a case where we think that it's enough useful to do this. Maybe we just don't see it.
I'm sure it would be a cool contribution if you wanted to.
And if someone has enough strong machine, he might just modify this line, this cutting, and get all that stuck.
It's a spoiler, it was for the end. At the end we do that.
But you will see
it's
the
performance
cost also.
Yeah, and now we're gonna see a lot. Yeah, it's better to interact with a smaller subset of your actual data.
Okay, and you see here comparison of these two widgets, which are mainly changing the type annotation.
Yep.
I was about to say something, I forgot.
I don't remember what I was going to say, but we can step on to the next one then. Okay, so now we have some basic infrastructure, we're doing some very basic thresholding, but what we want is to do segmentation of this data, right? So we actually want to have individual cells be separately segmented. So we need to add a few more steps. Now what we do is we just add things to our function. So instead of just having the sigma and threshold, we are adding some cleanup. We want to remove the holes that we were seeing in our data, and we want to remove the straggler dots, because we just want nice roundish objects to select everything where our cell is. So we add these two new lines. They're pretty much the same as before. We just changed the ranges and the sliders and the step, because those will be different for this type of function. And then we are adding, in the same way, some extra lines here. This is all scikit image stuff, so we're not going to go into detail on how they work. I don't know how they work, but the way what they do is important, which is remove the holes and remove the small objects. So we also, wait one sec, and then at the end we also do a measure label, and this is then taking every separate object and giving it its unique ID. And what we end up with is a slightly bigger widget with a couple more sliders. Oh yeah, that's the thing I wanted to say. Everything is kind of resizable in napari, so you can move there to the left, and now you get bigger sliders, so you're not working with half a centimeter. So now if you run, yes, if you run this once, it's going to do its first thing, and now we have a bunch of layers, and you can see, okay, now we're getting to the point where it's important to know what we're doing with the previous sliders, because you see that at the end we're getting a bunch of separate labels, and we don't want that. We want individual labels for each individual object, and we know that the object we're interested in are the cells. So to do that, we can move the various sliders. You have all of the intermediate steps, so you can see that the holes disappear and the small objects disappear in the next one if you move the last slider. And at the end, what we get is a nice segmented image. You will see that we still have some problems here, right? We still have some big holes. We can probably change the range of our sliders in order to allow for bigger holes to be deleted. Maybe we can play with the sigma. But the cool thing here is that you can do all of these things at the same time and see how they affect the result instead of having to run one by one all the various combinations. One thing that you will notice, maybe it's possible to get it right, but it's a bit tricky. You will notice that sometimes a couple of these cells are touching, and then they're going to be labeled as the same object. That's annoying. We can add an extra step later, and we will do it in order to make sure that this is no longer the case. Yeah, for example, you can see here these two are marked as one single object. So for the next step, we're going to look into a bit deeper into what kind of metadata you can add to napari. Let me stop here. Questions on this? Is it working? Does it make sense? Great.
You might see here what is needed to change to the labels for this one who don't experiment at the second file.
Yes. So here we, I think if you don't put it and it's a Boolean array, it will guess that it's labels, but or if it's like a small integer array.
Yes, it depends that if it's small integer, it guesses its image, or the bigger integer, it guesses its labels.
Okay. So the next one I think is features and points. Yes. All right. So let's look at some other types of data that you can work with in napari other than images and labels. So we probably want to know something about our cells. Something very basic that we can look at is how big they are, right? So we can just use scikit-image region props, which just does this. You just feed it a labeled array, and it spits out a table. And that table will contain a lot of information, and we just ask for the area. Tell us what the area is. But how can we then look at that area in the context of the data itself? Well, we can provide an extra argument to the creation of a layer, which is the features, and that's going to be a pandas data frame, or you can pass a dictionary or something compatible, and we'll try to convert it. And so you can see here, now instead of just passing the name, we are passing also the features. And we are also getting the centroids. Sorry, I forgot that. We're getting area and centroid of each cell. This line is just to make sure that napari knows what the index of the label is. But then we take that and make, with the centroids, we make a coordinate array, right? So this is an n by 3, because we're, no, n by 2 because we're in 2 dimensions. And we are passing that as a points layer. So when you put these things together, you're keeping all the intermediates there. It's getting busier, right? So now if you run it one more time.
Maybe close it.
Yes.
It's similar.
Right, so the number of layers is increasing, and now you see we have a points layer there at the end. Yeah, we can switch back from the grid mode. And the points layer will just show the centroids of the things that we found. As you can see, this is where it's getting problematic to have fused objects, because of course the centroid of those two cells is not what we are actually interested in. One thing that is nice now is because we provided the features table to the labels layer. If you select the labels layer and hover with the mouse over a label, you see at the bottom left, in general, Napari gives you something about the status. So it tells you the coordinates, and if there's some selected layer, it will give you some information about that point in that layer. So right now, if you hover over, well, you're doing it on the centroids, but you can do it also on the labels. If you select the labels, because they also contain the same information in the features, because we passed it to both, and you get all of the features on there. So we know now that that label has an area of whatever that number is, and you see also the various centroids up to n dimensions.
Later or not?
Huh? Yeah. Yeah. And this is another new feature, which is the features table widget. It's a built-in plugin, so it's using the same plugin machinery as we're going to talk about in a moment. But it's built in, and it lets you navigate all of these features that we just passed in. You can also modify them, select based on it. So right now, if you select a few columns, you should see that the same point is selected in the.
Yeah, that selection mark is.
Selection mark is too thin, so you cannot see it. You can actually, if you do this and show only selected, yeah, exactly. So now you can actually see exactly which label corresponds to that line that you're looking at. Okay, so we have almost everything, I think. Any questions on this? Yes.
I just how you put the how
What's the question, sorry?
have you seen how you create the features on results?
So it's up here in plugins, and you see it here. Or easier way is to open the command palette, Ctrl-Shift-P, and type like features, and it will pop up. Yeah. By default, it's down there for some reason. We need to fix that.
Because of adding is removing too many widgets.
Yeah. And depending which layer you select, it will populate with the selected layer. So if you now click on run some other layer, well, one that doesn't have features, it will say there's no features. So it's linked to the currently selected layer. And again, this is using the default plugin interface. So you can do the same thing if you make plugin. Okay. So yeah, I think I said everything about this one. Sorry, you had a question. Say it? Okay. Any other questions? All good? Okay, I assume that means it's working. Okay, so we can now add something else. We wanted to fix our problem of touching labels. For that, we can create a new widget. This one is getting already too complicated. And for this one, we're going to need two layers. So if you scroll down, this one we didn't touch. Of course, scroll up. We create a new function, same idea, same machinery. Now we have two inputs. And we ask for a points layer, we ask for a point layer, and for an image layer. We're going to use the image layer in order to create. Wait, is it the image or is it the
labels?
The labels layer in order to create our first base of segmentation, and then we use the watershed algorithm starting from markers that we chose in order to spread out inside that segmentation and basically separate the various blobs into individual blobs. There's an explanation on the scikit-image documentation for this, so we don't need to go into the details here. But the general idea is that you start from that point and you move outwards, going down the gradient, and find the neighboring points that are belonging to the same label. So if you the problem here is that you have perfect segmentation, so that's not going to help. There you go. Let's do a bit worse. So we have a few connected things. So what you can do here now is create a new points layer. You can create it manually by clicking on the little points on the left above the layer list. And now annotate, okay, hide the centroids. Sorry, go slower, I'm explaining what you're doing. He hid the centroids, so we're not getting confused. And then you're just clicking manually in the center of, or somewhere on each blob that you consider to be an individual cell. Then there you have to select the layers that you actually want to run it on. So in this case, the points layer that we just chose, and then the results from before. And then you press run. And this one we leave it pressable because otherwise it's more expensive to compute. And it runs, and as you can see now, it split correctly, the ones that were fused, these three up here. And also it just ignored everything else that we didn't click. So we can click more if we want them. We can also just go on like this if these are the ones that we are interested in. If we now go back and change the sliders from the previous one, we can make them change the output of the previous step, and then we have to rerun this one because they're not linked and automatically ran. We could do it, but again, this is a bit more computationally expensive. If you look at the code, you see that there's this intermediate step where you have to go from the labels that we had before, which is just an integer array, to a distance field, and that's how it navigates down the slope in order to make sure that one object is a single, one blob is an individual object separated from the neighboring blobs. But again, this is not a scikit-image tutorial, so we'll not go into details on that. You can see that we're still returning here the same way as we did before, using a layer.tuple, and down here we had to, of course, add this new widget. Okay. Is this working? Does it make sense? Yeah.
How do you make the points?
The points layer, by creating a new points layer.
Here.
On the left, there's that button. Sorry, I'm pointing there, but it's here.
This small button with these dots is creating empty points layer.
Yeah, but then how do you make the actual point?
You select this.
We're so used to doing this that we don't realize that we have to explain it. Yeah, you have to change mode. The buttons at the top of each layer control panel is the layer mode. So you can change to select mode, create mode, remove mode, and so on. This obviously I should have explained earlier and I forgot. This is also what I did earlier when I was deleting or creating a new label. It was the same idea. And you can, as you can see, you can select it and drag them around. You can also select a group and then delete them. It's going to interact more or less the way that you expect from image editing software.
My data control seems to be locked, so I can only on move camera. Can't get it to click.
I didn't get the question.
As in, mine is stuck on move camera.
Is it because you're in 3D?
Yes.
Yeah, I think there's some stuff that's disabled in 3D because it's either not yet implemented properly or it just doesn't make sense. For the points, we had it at some point, but it's hard to make it obvious where the point is going to land on the view axis, if at all doable in an unambiguous way. So just go to 2D and do it there. There are plugins out there and various tools so that you can annotate in 3D based on multiple layers, for example, by selecting an image layer and saying, okay, now snap my points to the maximum value on that image layer and stuff like that. But none of this is built in Napari. Yes?
Bit of a tangential question. Is there the concept of units in Napari, or is it all just pixels?
Yes, there is a concept. It's kind of being built by this guy at the moment, and it's at the moment you can provide units to the layers. They know what they are. You can see we have a scale of happiness in the bottom. That's a unit. Yeah, we just created a unit, but by default it uses the pint library to handle units. And so if you just maybe change the scale bar to nanometers or something like that, and it will be automatically showing, as you zoom in and out, a sensible scale bar with that unit. There is no linking at the moment, no cross-check. So if you provide a unit on the scale bar and a different unit on the layer, it will just go on like nothing happened. We are in the process of building up the machinery so that the units are used to, for example, adjust the scale and stuff like that.
For now, if you have all layers with added units, it impacts rendering in the proper way. So if you provide, because each layer has units information, and if all, for example, because it doesn't mean that all need to be nanometers, but there cannot be that on the z-axis one layer has nanometers and second layer has seconds. In such situation, we told, okay,
something is weird. Let's not do anything.
We don't know what happens now, so we just stop using this feature.
But yeah, we are in the process of building up the machinery so that all of these is going to be available, for example, also on the DIMS model, the dimensions, so that you know that a dimension is now composed of seconds times.
And you can access them all from within a plugin as well.
Yes.
Yes.
Sorry, follow-up question to that. So can you read the metadata of like image?
Can you read the metadata from a file, you mean?
Yeah. Like
Yeah.
Yeah.
So we're not talking about that here because there's extensive tutorials on the website about this, but one of the most common, the most common plugin that people develop is a reader plugin, which is exactly that. You just create a function that can read, can go from a file to Napari layers, and there you can do whatever you want, essentially. So if your file has metadata information, you can then give it to Napari. At this point, if you provide units, it will be used in some cases, like you were saying, not always. But we're in the process of making that like more full-fledged. The other stuff that you can provide will totally work. So scale, affine transforms, yeah, a lot of other metadata. Features, right, like the table, the extra metadata that we showed now, that also can just come from the data reader. Right now we're using this is a TIFF image, I think, and for that, like for a bunch of very common formats, we just have built-in readers. But most people's first contribution is a reader for their specific proprietary, crazy, weird data type.
And in following time, we will adding units from the TIFFs, for example, because there is a prototype. We need to just do this, but we need to think how to do this in a proper way, because for now our code is not reading units, and it does not read units. Is not a problem. Is that it's not reading the scale, and so if we start reading the scale from the file, and there is a user has his own custom plugin which does not read the scale, there is a confusion, because in the previous Napari release he drag and drop both files and it rendered pretty as he expect, and now one is landed in this different special structure than other. So this is the problem is not to add reading the scale. The problem is not to break most of workflows magically at the same time. You see that here that every layer has units, but it defaults to just the pixels. If someone is not providing, we are working how to guess unit if from the existing layers, if new layer does not having units provided.
Any more questions? Okay, so I think we can move to the next step. And yeah, a mouse callback. Okay, mouse callbacks are a bit more complicated, but they can be very useful. Right now we have a very dumb example of a mouse callback, but you can do whatever you want with it. What you need is a function that then takes an event. An event is a model that Napari uses and throws around whenever an event happens. You should be familiar with it if you ever worked with Qt. The important bit is that it takes as an input the viewer and the event will have a few pieces of information on it. It will have the event type and modifiers, if there's any. So like if you're holding shift while moving the mouse. It will also have the position of the event on the canvas, the position in the world space. Okay, so if you're in 3D or ND, where the cursor is in the world, and a few other pieces of information. What we are showing in this specific example is after a few guards. Can you go back to the code 1 second? After a few guards to make sure that we're not running when we are out of the canvas or when the event does not have the shift pressed and stuff like that. What we're doing is we're getting the value of the layer, and you see that we selected the results layer, right? We just took that one. This is hard-coded, but you could do something smarter here. And we're getting the value at the cursor position. And we have to pass some more information because if we are in 3D view, it needs also the view direction in order to know where we are looking. And we made it so that if you press shift and click, it pops up a little notification telling you the area of the hovered label. So yeah, this is a very simple example. You can look into the Napari code to see how complex these things can become, and you can have generators instead of functions, and this allows you to do drag and drop and more complicated stuff like that. The way most things like creating a point are implemented is by using this machinery. And I think this is the only thing we're adding in this. Yeah, of course, we need to append the event to tell Napari, hey, this is an event. So there's an extra line here at the bottom where we give it to Napari and say, this function, call it every time that the mouse moves, or any time that there's a mouse event. This stuff, we don't have a smart way to provide it as a plugin at the moment. So we will not use it at the next step when we make the plugin. But it's there so that you can see that it's possible. And you can play with it and just change what you're doing with that. Like for example, now we're just printing the area, but you could calculate something from it and create a new layer based on it and stuff like that. What's happening?
Too many widgets added, and the bottom of the window goes out of the screen.
Oof. Okay. So, any questions on this? This piece of code is a bit messier, so I think it's easier if you look at it at another time. But the last step is super simple because all I did is change the line where we loaded the 2D data and instead load the 3D data. So you can see that all of this just works exactly the same in 3D. You don't need to specialize anything for it to work in 3D. And you will also see that here, if you start playing with the sliders, Some of them become a lot more important. Like for example, the first Gaussian filtering has a quite big impact in the presence later on of holes in your cells, and you will have to, for example, increase the hole size, the minimum hole size, to much bigger, because now we are in 3D and we get three-dimensional holes. Also, now you can actually use the slider at the bottom because we're in 3D, so you can move through the stack and see how your segmentation affects the various slices. You can also right-click on it and change the thickness, and it will show you more slices. This is especially important for the points, because the points are so small, because they're points, that they will just disappear in the neighboring slices. You will see that there's nothing special happening for the labels at the moment when you increase the thickness. That's because it's not yet implemented, but everything else you should see a bigger chunk of your data when you change the thickness. Also, one thing that you can look up now maybe is transposing the dimensions, and we can look at them in other orientation. So you see now that at the bottom left of that slider it says 2, because now we're slicing through the second dimension instead of the 0th dimension, because we transposed. So we're moving along like this, then you change it again, and now we're moving along like this. And going back to how we were. And you can also, of course, just simply switch to 3D and still do the same stuff while you're in 3D. And just remove small objects. Okay.
How do you rotate the image? To rotate.
To rotate the view?
Yeah.
Just drag and drop on the canvas. Like this, you mean?
Yeah.
Yeah.
This is mouse clicked and moving mouse.
It should work the same as. It should work intuitively the same as other 3D software.
Check if in your active labels this cross which I point to mouse is selected.
It should be in move mode and not in select or add points mode or something like that.
Or you might just keep the space and then it should start working, even if there is a door mode.
Yeah, hold down space and drag and it should work. I thought there was another question I saw there. No?
So okay, you see, we just developed a whole pipeline on 2D data, and because we select proper libraries for scikit-image, which is not strictly connected to the 2D data, we just load 3D data and it works in most situations. Of course, for example, if you use Pillow, it will be more 2D data centric. So you need to be worried. At this moment, we could only tell that this is the by type annotation, this image data, not 2D image data. And maybe before we go to the plugin generation, is why we decide to, because what could be widget? It could be functional widget, it could be Magic GUI, you might call the proper function from Magic GUI directly to generate widget, or it could be Qt widget, just generate by Qt, writing Qt code. From our experience, the Qt code is harder, but if you try to do something more complex, please not be stuck to the functional widget, because we see some monsters in the code.
We have done monsters. I have done many monsters.
So Magic GUI provides also option to build from the blocks. You may create a container and then put in the container some of type of floats. What is nice with Magic GUI? We are on the road to make option to run napari in the browser. It's on a roadmap. We do various. At this moment, we prepare database. We find places where we a little too much depend on the Qt and moving to the pure Python. And what is nice, if the plugin is Magic GUI, it will work. It should work with the web version, not like the plugin which is created with the Qt directly.
Yeah, and if you use Qt, please don't use any specific Qt. Instead, use QtPy, which is like a abstraction layer over PyQt5, PyQt6, and PySide 2 and PySide 6, so that it will work the same, but it will not conflict with other people who are developing. And this is important when you're going to start using multiple plugins from multiple people, and you don't want them to, and you want them to run in the same environment, and that's the main thing. Any questions on this part? Okay. So basically, we are happy with our pipeline. We can now use it. We want to just give it to some colleagues that now can just actually use it on some data sets. How do we do that? How do we make this into a shareable, easily installable thing? We want to make a plugin. And you can do that very easily by using the plugin template that we have. There's instructions on the README there on how to use it. It's essentially one line. You use this tool called Copier, and it will prompt you with several questions, and it will generate a plugin based on how you answer those questions. It generates a repository ready to go, basically, with also the various pieces of CI and linting that might be useful for you.
Okay, so I opened because we convert this code to the plugin, I open the repository which is linked here and go to the commit which shows differences from this what plugin template Copier provide to this what is needed. So as you may see here, this part is just copy the function, just copy the file which is in our code.
So the 08, the last one, just literally copy pasted into there, and we use that now as our module.
This part is obsolete, but we just want to show because this if will be always false, but we would like to show, just copy this what you have. The only important things is this napari YAML, because in the past we have that, okay, we discover the plugin, we load it and inspect and see what happens. But unfortunately, napari starting very, very slow. People are not doing proper way. They're, for example, fetching some data from network or only important things, so on. So people are install some plugin and then napari starts for 3 minutes. That's maybe not the best. So we are forced in this way to go to the declarative system when you need to provide in napari YAML information about, okay, we provide two things. There is these two. This first is here, the long plugin name, and then told threshold and labels. And here the watersheet. And we told that these two commands are just widgets.
So just to go a bit more into detail, here you're looking at the diff here, is that right? Yeah, okay. So the stuff that was generated by the plugin template is the basic Python package stuff, right? So you're going to have all of your directory structure and your PyProject and all of those things. Then we just drag and dropped, copied this file that we generated earlier.
You see on the left, there's whole big structure.
Yeah, the git ignore, all this stuff. But we can ignore it for now. And in here, in the source, where is it? Am I lost?
This is the first commit, so there's no.
Okay.
You go back to.
So this is just to show the only things that you have to modify in order to make this pre-built plugin into your plugin with your stuff. And the important bits to keep in mind here is that you have to provide commands, and these are essentially actions, like a function, a thing that does something. And then you have to say later what those commands are used for. So here, for example, we provide a command, you give it an ID, and usually you put the name of your plugin dot some specific command ID. This is just a human readable title for the command, and this is the full Python path to reach that. So this is the package.
This is what you need to import when you open the console.
Exactly. So this is basically from here, import this essentially, and we do it for both of our widgets that we created. And then here in the widgets, we have to declare those widgets as widgets. So we say, okay, this command that we declared earlier, and we provide the ID from here. It's in the widgets. We provide a name for the widget. This is what you will see at the top right in the title of the little widget interface. And also we provide auto-generate true because this is a functional widget, right? We are just giving a function. We're not giving a pre-created Qt widget.
The name that will be also visible in the plugin menu.
Yes. So this features table widget is called like that because the title is called that. Another thing you can do, you don't have to, but you can, is to say, okay, I want this these specific things, these specific commands to appear in the menus. And we have the documentation that explains in detail where you can put things. This is one of the examples. You can put it in napari layer segment, and because of course this is a segmentation plugin. And so we provide the IDs of the commands that we want there. So once you put all of these together, so this is the only modifications that we had to do. If you now run this, you have to install this plugin in the environment where we are. Forgot to do it beforehand. But it should be pretty straightforward. Did you have to UV pip maybe?
Activate.
Yeah, and some of the stuff that the plugin template will pre-generate for you is all of the machinery to also publish on PyPI. So you can publish just by tagging a version v something, and then CI will kick in automatically, generate a version, publish on PyPI, and it will be available. Anything that's published on PyPI and that has the Napari framework identifier, I don't remember what's the terminology for it, but that will appear also on the Napari hub. You can also opt out of it. You can say, no, I don't want it public, so that's not, like, you don't have to do it. But otherwise, by default, it will be on the Napari hub, and so it will be searchable and easy to find for other people. Yes. So you see now, after installing that plugin, we now have in the menu those widgets that we created earlier, and they have those titles that we gave before. And not only they are in the plugins menu, but they're also available in the layers. Yeah, they're available in the command palette, so you can just search for that, and it will find it and you can run it. But they're also available in the layers segment menu.
And you may see that I might open it from one place and close from other place. This is synchronous.
Yeah, it's the same thing. Question.
Do you have to specify the metadata of your plugin which versions of Napari is compatible with, or is it
just Python specifiers? Like for any Python. If you put the Napari dependencies, Napari in the plugin dependencies, you might told, okay, it is compatible with Napari in version at least X, and or at most Y, because we know we are a young project. We break sometimes something, but maybe there are also a problem that someone is create a perfectly working plugin which will still work because we don't break anything in it, but he by preference told, oh, I'm compatible with Napari version up to something, and people are in struggle and need to only fork something only to remove this little small classifier that. But yes, minimum version is just as any Python package.
But the metadata, the YAML, napari.yaml itself is not versioned at the moment, if that's what you were asking.
No, I think I was talking more about the Napari version, but of course that's just the Napari version at the time. So yeah,
okay.
That's my question.
So we show how to create a given type of widget plugin, so functional. This is the easiest. Is the easiest to convert normal your own functions to widget. We love it in the, for example, context. You develop something for your friend who is biologist or other stuff. He know better about the data, but he don't know in the programming. You wrote it, wrap it everything in the function, add small type annotation, and you might either by drag and dropping a script or creating your own plugin, give it to him and told him, okay, you have your data, here you have the methods, you might adjust parameters, don't bother me that my adjusting parameter is not working for you. Of course, what Lorenzo told earlier, not only widgets contributions, we have at this moment reader and writers, so it's totally different type, but it's also possible. And theme, yes, you might change, one of the most important thing for any application, you might change the theme and
by default there's white and dark, and I think there's only one theme plugin out there which I made and no one else. But
we also have planned to increase ability to do this with
like the mouse callbacks or just shortcuts. Shortcuts are all customizable. You can provide shortcuts yourself as well. We didn't go into details on that. You cannot yet do it via plugin, but you can do it via your own script. There is no like nice API via the plugin to do it. However, there is also, because you can annotate anything in a widget as viewer, napari viewer, then you will get the viewer from it. If you do that, then that gives you access to the full viewer. So a lot of us, when we need to do more complicated stuff that is not yet available nicely via the plugin interface, what we do is we annotate one argument as viewer, and then once the plugin gets popped up, you can start doing shady stuff with the viewer without asking permission.
One of the reasons why you cannot just declare shortcuts is that some of shortcuts will be popular in every plugin until you mess, and this is we collect also information from potential users about what they want and so on to provide an interface that will allow at least reduce number of conflicts and still keep usable.
Everyone wants to use shift click.
We have something.
Other questions on this part? Did anyone try to run the template? No one? Oh, yes. Did it work?
Yes.
Nice. Okay. You can also easily look it up later, and of course, feel free to pop into the issues and open an issue if something is not working. Are we finishing up? I think so.
Give a second.
Any general questions that are not related specifically to this, but about Napari or the weather?
So you mentioned at the beginning that Napari works with different kinds of arrays, so you support alternative to NumPy, like PyTorch maybe?
PyTorch, I don't know if I ever use. So there are some that just work without having to worry about it. When it comes to images, there's what's it called? TensorStore, Dask. This is a big thing actually that I didn't mention, but a lot of people really care about working with big data that does not fit in memory, and Napari has built-in machinery for all of that. So if you pass a chunked array, a lazy array, it will just work. Of course, if you try to visualize it all in 3D, it will try to visualize it all in 3D. We also have a multi-scale system so that you can pass a pyramid. It's not yet implemented for 3D, so it works in 2D.
In the context of 3D, it uses lowest resolution from the pyramid. So not the highest, so at least it's try to not crash your computer.
Yeah. So it will use a few of these lazy arrays as well. PyTorch, I never tried. I cannot tell you.
So do you have your own dispatch mechanisms to support different libraries, or do you use an abstraction layer such as the array API or something like that?
We have some custom code. We are going in the direction to provide at first we would like to depend more on array API. The biggest problem, which is not standardized yet, if I correctly know, is the chunking. And I think that we will go in the direction that, okay, there is a protocol for a wrapping array. We have uniform interface to ask about chunks. And then you might provide your own wrapper to this data type, and we'll be happy to handle this. It's not implemented yet, but it's on our roadmap of the refactoring on the road to the napari in the browser. And the last thing, which is also mentioned, the Jupyter. You could interact with napari from Jupyter. So you create the napari. I show the viewer, so you might see that even I interact here. And when I do, for example, screenshot, okay, it's the same what you see here. If I might, for example,
delete a layer. Yeah, so you can do all of the things that we did now by running napari from either an IPython console already or from Jupyter, and those things will be replacing the console that you otherwise open from napari, and then they will be linked directly as you would expect.
I see. I changed the color map to red. It changed here. So yes, it's possible to just interact from the notebook. It's possible that if you have your machine learning or other workflow where you work on multiple things and you would like to just preview the data in the middle of everything, you don't need to depend on the matplotlib rendering. You don't need to save the data and load it in the image, for example. You must just spawn a window, and even you might fix annotation. For example, you spot, oh, I need to fix this, but I don't have time, so let's manually erase these things and see if everything else is working. Of course, I don't advertise too many manual updating of data, because if you don't do proper script to do this automatically, you might end with wasting of time of manual erasing or adding something. But yes, it's sometimes worth, okay, I need to check second phase and I might do small modification because this will be in the memory. And for the one limitation for the labels, we do not support painting for other labels than single scale, because we don't determine yet how to interpolate. If you don't painting for the best resolution, we don't know to decide what is the best approach to interpolate painting from the lower to better resolution. Maybe we might talk somewhere during the conference about this, because it's something like we don't have clue what is my best idea for this.
Any more questions? Yes.
2 questions. When it comes to working with layers on different scales, how does it solve interpolation with them, or does it just say, like, I guess nearest neighbor interpolation?
You can set the interpolation on the layer controls for each layer.
Cool. And second question is, do you know whether
There's interpolation selector.
Okay.
Yeah.
Awesome.
And that's a subset. You can also pass other stuff programmatically.
Awesome. And another question, do you know whether this is used a lot in geospatial data? Because I think this could be very useful for, like, visualizing that data output.
We know that there are people who are using this in geospatial data. Unfortunately, at this moment, none of core developer is from geospatial domain. So we rather hear on some conference, sometimes we catch some papers, but unfortunately we don't have insight from someone who is using it and talk with us to show. We see the results, we don't, for example, get feedback on the inner problem.
Okay.
But we have seen several people. I would say it's a lot, but there are several people doing geospatial data analysis with napari. I know that there's regularly questions about how to better do with the longitude and latitude and stuff like that. So I saw a question up there. No. Okay.
Okay, so we'll be here for the whole conference. We submitted that we will be on the Friday summit with hacking something around napari.
For the sprints, yeah.
Sprints, yes, sprints. And you might catch us with some questions, some suggestions.
Yeah, and on the repo at the bottom of the README, you also have a few links, useful resources, both for the tutorial, but also there's the Zulip chat, which is, if you don't know what Zulip is, it's basically like a open source Slack alternative. And we are very active there, and if you have any questions, suggestions, or things to show off, you're very welcome to show up there. And yeah, we also have community meetings every week, and every week alternating. One is friendly for the US, Europe time zones, and the other one is for Australia, Europe time zones. So yeah, you can always pop up there and show something that you did or ask for questions and stuff like that.
There is also Australia, Asia, US meeting, but you might not expect any of us there. We both live in the Europe, but maybe some of you comes from Asia or US on this.
Yeah, so I forgot I was there. Okay, I think we're good. I don't see any more questions. Right, thank you for your attention.
I've got a couple small questions, just in case I don't catch you guys later. Non-orthogonal slicing, is that... No.
Not yet.
No, is it on the roadmap?
If you try, it will say non-orthogonal. There's a pop-up that tells you.
I've tried that. So one of the things I work on is rotating a volume in 3D and wanting to visualize 2D. The experimental clipping planes. Are they still experimental? Have they?
There's a couple PRs that I have one PR open to implement a widget to work with it. You know Chimera for molecular visualization. No. Well, basically, it's a little widget where you have a side view, and then you adjust two planes, and and you update the planes that way.